Now, in the next few slides, we will walk through a radar presentation and spotter observations of tornadogenesis. Now, before we dive into some additional radar data and storm photography, let's review a couple of important low-level mesocyclone features. The first is the wall cloud. Recall from the basic SKYWARN presentation, the wall cloud is a visual manifestation of the low-level mesocyclone. When observing the wall cloud, the airflow will generally be toward the feature of interest. This is due to the relatively lower pressure associated with the wall cloud. The wall cloud will occur in an area largely free of precipitation, though occasionally smaller rain and hail particles can be drawn into this area of inflow. A rotating wall cloud indicates an intensifying low-level mesocyclone and increases the chances for a tornado. If you are to observe a tornado, it will likely occur here in this largely precipitation-free area. In this picture, we observe a well-defined wall cloud in a rain-free area. We can be confident that this is a wall cloud as there is somewhat of a laminar structure. You may have noticed a small appendage here in this picture, which may be a developing funnel cloud. Next, let's dive into the radar imagery. Now, the radar is located at Dodge City, near the KDDC lettering in the imagery on the left and the right. And at 5:48 p.m., the reflectivity imagery on the left shows an ill-defined hook echo, but the hook itself is characterized by lower reflectivity. This is due largely to the lack of scatterers. If we examine the velocity data on the right, we do notice some very broad rotation. Given the proximity of the storm to the radar, it's quite possible that the radar is actually sampling the low-level mesocyclone. And again, this makes sense given the appearance of the wall cloud that we see in the imagery. It should be noted that the star indicates the approximate position of the storm spotter. Roughly 15 minutes later, we see that the wall cloud has persisted with a more defined funnel cloud. The persistent wall cloud coupled with the more defined funnel cloud indicates that the tornado potential has increased. Now, if we examine the radar imagery, we see that the hook echo becomes more evident with some faint, though greater, reflectivity values. If we review the Doppler velocity on the right, we note that cyclonic convergence has increased and is more pronounced. Again, the spotter observation in tandem with the radar imagery yields high confidence that tornadogenesis is underway. Rapid tornadogenesis takes place in the next 4 to 5 minutes as the funnel cloud finally contacts the ground, and we can see that a debris cloud develops, giving us high confidence that the condensation funnel is actually in contact with the ground. Remember, in the initial phases of some tornadoes, the condensation funnel may not necessarily be completely visible from the ground up to the cloud base. One recommendation is that when the condensation funnel is at least halfway to nearly 3/4 of the way to the ground, it may be a good idea to look for signs of a circulation on the ground, and the appearance of a debris cloud is one of the better indicators. The radar imagery confirms what the observer sees visually. At 6:05 p.m., the Dodge City, Kansas radar indicates a much more pronounced hook echo, and the reflectivity values have likely increased due to the ingestion of grass, dirt, and dust by the vortex itself. The radial velocity image on the right reveals a pronounced rotational velocity couplet associated with the tornado. "5 minutes, or around 6:09 p.m., the tornado grows from having a rope-like structure, as we saw in the previous image, to one of a pretty sizable cone. Not discussed previously was the presence of an outflow boundary nearby, which likely was ingested quickly by the supercell such that rapid growth of this tornado occurred. This supercell ended up being a cyclic tornado producer, And at some time later, the tornado would occlude with the supercell producing another tornado to the east. From a radar standpoint, we have very high confidence that a tornado is in progress with a well-defined debris signature in tandem with a very pronounced velocity couplet. That debris signature that I'm speaking of can be located here in the hook echo with the higher reflectivity, and we see that that corresponds to a very tight gate-to-gate rotational velocity couplet.